Hi ladies, I want to just go over the topic of energy with you. So it's obviously junior topic. The bits you need to know in this, girls, are what it is, what are the different types of energy, what is the law of conservation of energy, what are energy conversions, how do you work out the percentage efficiency, Bayer rating, what it is and how it's done, Sankey diagrams, what do they show, and what is renewable and non-renewable in terms of energy sources. Now, first of all, energy, what is it? So it's a word we obviously use in daily English, okay, and we throw it around. In science, we define it as the ability to do work, and it's measured in the unit joule. The different types of energy, guys, you'll be very familiar with these, okay? So you've got light energy, you've got thermal energy or heat energy, you have nuclear energy, chemical energy, you have kinetic or movement energy. All of those different types of energies, girls, I'm sure you've heard of before, and we're going to be talking about those and how they can convert between each other. Now, when we talk about energy and somebody's saying, oh, I have no energy today, okay, girls, that's not technically the case, okay? And we have what's called the law of conservation of energy in science. So that means energy cannot be created or destroyed, only changed from one type to another. So there's a little image there of a bowling ball hitting a number of skittles, okay? So the kinetic or movement energy in the bowling ball is being transferred to those skittles, where they then have kinetic energy, they have sound energy. There's also probably a little bit of heat energy there as well. So energy is always there, but it's just changing from one type to the other all the time. Now, in terms of conversions, girls, and how this comes up in exam questions, so energy conversions, girls, if we look at a radio, you've got electrical energy, if it's plugged into the wall, being converted to sound energy. So that's a type of energy that we want from a radio. You look at a TV, you've got, again, electrical energy being converted to light and sound energy, and sometimes a little bit of heat energy, which you don't want. So that's not a good energy transfer, okay? That's one that maybe that's unnecessary or one we don't want. If we look at a runner takes in food, that's chemical energy, and she's converting it to kinetic energy. Again, there will be some unwanted transfers here as well, such as heat energy being created too. For plants, girls, if you look at photosynthesis, plants are able to take energy from the sun, and they're able to convert that then to chemical energy in food. So the word efficiency what does the word efficiency mean? So efficiency, girls, is how good an appliance or an organism is at converting from one energy source to another. Okay, so if we look at the runner here, the runner wants to convert as much of the energy in her food, the chemical energy in her food, to kinetic energy. There will be some loss of energy here in terms of heat, girls. Okay, it's almost impossible to get a completely efficient organism or a completely efficient appliance. Now, in terms of percentage efficiency, so I've seen this come up in your mock papers, okay? So that's where we measure how efficient something is at creating the type of energy that we want. So you take the useful energy, so if we're talking about a lamp that gets 1,000 joules of energy, okay, and it produces 100 joules of light, we put 100 joules over 1,000 and we multiply that by 100 and we work out then that its percentage efficiency is 10%. Now, that's a pretty bad lamp, okay, if its efficiency is 10%. You would probably go looking on Amazon for another lamp that's more efficient than that, because you're going to be paying for the electricity to go into that to give you only a small amount of light. Now, in terms of houses, girls, when people are buying houses, they look at what's called the Bayer rating, the building energy rating, okay? So what that is and how it's done. So you're looking at how good your house is at storing heat energy. So the way it's done is we pump a house full of hot air once all of the windows and doors are sealed, okay? So they're sellotape shut essentially, and we measure the length of time it takes for the heat to return back to normal, okay? The longer it takes, the more efficient the house is, the better it is at conserving heat. So that will be like a brand new house would have a Bayer rating of A, okay? A really old house would probably have a Bayer rating of G, and it's going to cost somebody a lot of money to heat. In terms of Sankey diagrams, girls, what they are, so they are a really efficient, nice diagrammatical way of looking at energy transfers. So we look at electrical energy here. We've got 100 joules of electrical energy going into a bulb, and 75 joules of that is going to be going into light energy, and you've got 25 joules going to be lost as heat energy. So it's a really nice, easy way. By comparing the arrows, we can see which are the most efficient light bulbs or which are the most efficient appliances. So we always want the appliance that gives us the bigger arrow with the energy transfer that we want. In terms of non-renewable and renewable energy sources, girls, this is kind of a hot topic right now, I suppose, because of Greta Thunberg and because of all of the climate change and global warming talk there has been over the last while. So if you look at this little diagram below, so looking at the renewable sources of energy, you've got wind turbines, you've got tidal energy, geothermal energy, that's energy that comes from the centre of the earth, from, you know, the way the centre of the earth is hot. We get what else is there? Wave energy, solar energy, all of those things are never going to run out on us, and they're carbon neutral. They do not lead to the release of carbon dioxide into the atmosphere, which is negative for global warming, okay? Whereas non-renewable forms of energy are your fossil fuels, your oil, coal and gas, which all lead to the production of carbon dioxide, which is again negative for the atmosphere, negative for us, okay? So over time we are trying to switch to more renewable sources of energy, okay? And that's how it generally comes up. So you should know a number of examples for each. Now, girls, I'm going to set you a number of exam questions based on what we've just done. Any questions, just email me. Thanks, girls.